Hello and welcome to today's how-to demo. Today we'll show you how you can simulate network outages. Why would you want to ever simulate a network outage, first of all? Well, oftentimes if you are working on a network design that requires redundancy, or you're the developer of an application that extends through the network, for example, a distributed application, you want to test your network configuration or application behavior with simulated network outages. Of course, such outages should be applied to a control environment like a lab. So remember not to do this in production if you don't want to pay the consequences, I'm sure. So really, the easiest and simplest way to simulate a network outage is to shut down a node, for example, say the primary router, and see what happened to the traffic. Hopefully the secondary router, if your configuration is right, takes over immediately, and no or minimal loss is perceived by the user. The same for the application. And of course, like, turning off a node is the easiest and simple failure scenario that you can and you should be running in your test environment. More complicated ones might require you to increase packet loss or introduce latency, for instance. For that, there is a Linux command called TC, which stands for traffic control. In other occasions, you might want to saturate the bandwidth, and for that you can use a packet generator. There is iPerf, which is a traffic generator for TCP and UDP traffic, and that can run on any Linux or also Windows host. So that's very good to see how your network or your application behaves when the network is oversubscribed, for example. Lastly, I also listed failures of two network services that are pretty important for the correct functioning of the network, which are DNS and DHCP. So to simulate a DNS failure, it's very simple. You can, for example, configure your DNS with a wrong, incorrect DNS name server, so nothing will be returned. Or in the case of DHCP, you can filter packets with the firewall, just to see how the clients would behave when they don't get a DHCP address, which of course would be, they would not be able to connect to the network oftentimes. So for the purpose of the demo, I wanted to simulate and show you how to introduce packet loss in your network with traffic control. For that, I'm using NetBeez. Here you can see I'm selecting the Pittsburgh 2 agent, and in this agent I configure a high frequency ping. So every second I'm pinging an internal destination, and as you can see, this ping test is pretty clean now, as all the packets are returning. And what I do, I go in the console and apply a TC traffic control rule. To do that, I have to gain root access. So here is a string a command that applies a 10% packet loss to my ETH0 interface. And let's see here what happens. At the same time, I also applied on NetBeez a rule that applies that triggers an alert when the system detects a packet loss for the last minute that is higher than 2%. So you'll see very soon the first packet failing, and NetBeez trigger an alert as a result due to the increased packet loss introduced by TC. There you go. You can see that the packet loss so far is 3.4%, and of course this is going to increase as I keep this rule in. So this was a very simple simulation with traffic control, increasing packet loss, but of course you can do many other failure scenarios. You can increase latency, or you can also restrict bandwidth with traffic control. Of course, if you want to saturate bandwidth, you would have to use iPerf or a packet generator. If you want to learn more or even try NetBeez for distributed testing, you can check out NetBeez at netbeez.net, NETBEEZ, or check out also our blog, as we have also an article that shows you how to use traffic control. Thank you so much and have a great day.